So you've learned how to differentiate trig functions. What can we do with that? Well, the main applications of differentiating are we can find the equations of tangents and normals, and we know how to do that. We need to find the gradient there and a point, and then throw it into y minus y1 equals mx minus x1. The other main point of differentiating is so that we can have an easier time when we're curve sketching. So let's have a look at an example of each of these. Find the equation of the tangent and the normal to y equals cos x when x equals negative pi on 2. Alright, so let's do the tangent first and then we'll do the normal. To find the gradient of the tangent, we need to find the gradient of the curve at this point. So what do we need to do first? Differentiate y equals cos x. So even though you can do that in your head because you know it's a really simple result, it's important to write down all of the steps that you've used so it's really easy to follow your working. So we've differentiated it, and this is what we get. So what do we get when we sub in our value of x negative pi on 2? Well, when we do that, our gradient is going to be negative sine of negative pi on 2. Now, there's a lot of ways you can proceed from here. You could reach for your calculator, put it in radians mode and find out what that is. It's probably actually quicker though to think through what your curves look like. I've got the sine curve as something that I can very easily and simply draw in my head. I know that it goes like that, and a quick squiggle, I've got it there. So if I know that this is 2 pi, this is pi, then over here, negative pi on 2 is where it's down at the bottom of its curve here, just to the left of the origin. So I know exactly what the sine of minus pi on 2 is. It's negative 1. So if I have negative 1, then that just gives me 1. So there we go, I found my gradient there. And you can verify that with a calculator if you want to, or it might be one that you just know. But I think using the graphs makes a lot of sense because you're always checking that your answer is meaningful to you somehow and not just something that your calculator spat out. After all, if you forget to put in the right button or something like that, you have the wrong answer. So calculators are only as good as the people typing in the buttons. All right, now we've got the gradient, we need our point. We know the x value, what's the y value? Well, let's ask ourselves when x equals negative pi on 2, what's y? Well, y is cos of x. So that's cos of minus pi on 2. Now I've got the same strategy with this. I know the cos curve really well. Starts up here at 1, goes back up to 1. So when it's minus pi on 2, this is pi on 2, so minus pi on 2 is over here. I know that the cos of minus pi on 2 is 0. And that's really easy for me to do. It's probably quicker than me putting it in my calculator. All right, so now I need to just throw it into this formula. I've got my point, minus pi on 2, 0, which makes this a 0. So y minus nothing, I'm just going to write y. My gradient is 1. Well, I'm not even going to write that because 1 multiplied by something, I'll just put the something. And I've got x minus pi on 2, which is plus pi on 2. Okay, so that is the gradient of my tangent. So once I've got that there, I can put a box around that so it's really clear to an examiner what it is that I think I found there. Now to find the normal. Well, the normal will have a gradient that is the negative reciprocal of the tangent's gradient. So it won't be 1, it will be minus 1. So now I can throw it into this same formula. It's got the same point exactly, because when x is minus pi on 2, y is still going to be 0. So now I can say the normal, I can probably just go to writing it straight down. I've got y minus nothing again, that's just y, equals, now my gradient is negative 1. And then I have x minus pi on 2. So I've got my x plus pi on 2 again. So you could write it out like that, or if you've done that in your head, it'll be fine to jump straight to the answer. I prefer to just make sure I don't make a sign error here. I think this line is worth doing. So my normal is minus x minus pi on 2. And that's my normal there, so I'm going to write that down. And there's my answer for my normal. All right, when we get to the end of a question, always think back, does this make sense? Does it fit with what I know? Well, we're talking about the curve y equals cos x here. Let's just draw it a little bit bigger. It goes like this, And we're thinking about this point over here at minus pi on 2. We know that from there it dips down. So, does our answer make sense? Well, the tangent right here is going to have a gradient of 1, isn't it? And it's going to go up like this. And it's going to go through, up here it's going to go through pi on 2. So it makes sense, it's got a gradient of 1 and it's going to go through pi on 2. Because if that's pi on 2, that's pi on 2. So it'll sit up here somewhere, so that seems right. And then the normal at this point is going to go the other way. So its gradient will be -1, that looks good. And it's going to cut through not pi on 2, but minus pi on 2. So checking your answer makes sense just with a simple little sketch is a great way of spotting any mistakes that you might have made.